Well, I think it's time. Welcome everybody to our second webinar organized by RISC2 project. Let's start with a short bio of our speaker. Let's see. It's a very interesting talk about interactive high-performance computing with JupyterLab. And bueno, here we have Chance. He's graduated in mechanical engineering a couple of years ago and worked until 2014 as a research assistant at the Institute of Technical Combustion in the area of turbulence modeling and high-performance computing. He joined the cross-sectional group Immersive Visualization of the Hewlett-Aachen Research Alliance, part of the virtual reality group of IT Center in Aachen University, and became part of the cross-sectional team Visualization of the Hewlett Supercomputer Center in 2016 as an expert in visualization of large scientific datasets, in-situ visualization, and coupling and interactive supercomputing. So we have a space for talks at the end of the talk, for questions, sorry, at the end of the talk. So you only need to write it down in our chat window, and we will discuss with Chance at the end of his presentation. So thanks a lot, Chance, for being here, and well, welcome to our webinar, and the air is yours.
Thank you for these kind words, and I'm happy to be here having the chance to talk to you, because I'm really convinced that interactive HPC with JupyterLab is an important topic to talk about for multiple reasons, especially for making more science out of the limited time everyone has. And we came into pushing that years ago because we saw that the workflow of visualization needs to be linked closer to the workflow of pure HPC. So that's my my reason why from visualization I'm passed over or spent now a lot of time with interactive HPC, and yeah, it's my passion here. So I expect that you see my slides. If not, let me know, because I see them here on my screen at least, and we'll go to the first slide of the talk. The motivation. What for should one actually think about interactive HPC? Everything works fine in the terminal. I used the terminal for years and years and years and years, and that's I'm used to seeing a cursor all day, but when one thinks of the limited time, as I said, one has then perhaps a better interface to the machine is nowadays needed. And the more complex the systems are, but also the more different domains are joining into use HPC systems. And here's one sentence from the founder of Jupyter, Fernando Perez, and he said, I think that fits quite well. It's all about using and building machine interface between computational researchers and data supercomputers, laptops, cloud, and now the most important part of the sentence, your thinking, your reasoning, your insight, your ideas about the problem. So how can you make science with an HPC system in a way that it feels natural? And this question, how that can be done, is a question which was thought about quite some years ago. Here I just put I would say the most, at least from my point of view, the important steps on the way to JupyterLab in the table. So 2007, IPython started, and from that 7 years later, Project Jupyter was a spin-off, and because it was so so popular. And here I put the year 2015 when GitHub also decided that they can render these Jupyter Notebook files to show the result right in the browser. That I think is also something which shows that it became more and more popular to use it. And on the right you see a plot. Of course, it always depends how do you plot things. Here, this plot was generated by looking at all the repositories of GitHub and checking how many of these repositories have Jupyter notebooks inside, and there you see that it's really rising dramatically. Yes, it just goes to 2018. I'm sure it would show even more Jupyter notebooks in Git repositories at GitHub if I would have taken the time to go on with these plot. But I just want to have it here as motivation that it makes sense to look into that. Yeah, in 2018, JupyterLab was announced. That was also the time when we jumped in and said, this is really promising, and let's try to allow users to use this JupyterLab, because it became more and more a complete environment where you can do your workflows, your everyday work, your science. And 19, version 1, version 2, version 3, and now work is going on for version 4. But perhaps we just go one step back. I know probably parts of you are knowing this already, but to ensure to get everyone on board, I go through the basics. This is actually comprehension of a 3 days course. So I try to put 3 days into 50 minutes. And I'm sure that will not work out, but you at least have the chance to contact me or anyone at the JCUs into this topic. And there are quite some on that. To contact them, we can dig deeper into the possibilities. So Jupyter notebooks, what is the main idea? I said it already in the beginning, in the motivation in these. It's about your thinking, your ideas. How can we tell a story? How can we make our science to become a reproducible computational narrative? Let's call it that way. So how can we have everything in one place, in one file, in this saying that way? Everything which means comments, means codes, means outputs in the sense of graphical outputs, in the sense of plots, in the sense of any kind of extras which extensions can put in here to make your ideas and what you want to tell, what story you want to tell, to make it the style that way that you can pass it to someone else, and he reads through your document and he can run your code. He can understand what's actually the ideas behind it, what are the results, and not just other people, but also oneself. At least I can say from my point of view that when one has done something a few months ago and one goes into that topic again, then it helps. If it's if the time you spend in getting into these overhead you spend to restart with the things you're working on, it's really worth lowering that a lot. Not only if we're talking about things which are a few months ago, even if it was yesterday or a week ago. So there are good reasons to show and to present and to make the research more, the presentation of the research and the work environment more human usable. And having a look at the history at JupyterLab at our institutes, as I said, we started in 2015 with just providing JupyterLab on the system as a module, and thinking how can we allow users to just use these JupyterLab fully from the browser. So no SSH login anymore, just the browser only. That means you have to think a lot about authentication, authorization, who is allowed, how do you ensure people can log in, and how do you secure that? How do you ensure which resources they are allowed to use? How do you ensure that this is this scales, this setup? So things which are probably nothing to worry about if you are just starting JupyterLab in the user space, but if you want to have it as an alternative entry point to the HPC systems, then there's quite some few things to consider, even talking about data protection regulation. And yes, that was the first steps in which were happening in the background. And 2019, thinking about how to increase the usability, to include more features, and of course always in interaction with the users which are actually on the system. What do they need, and where we can push that further. New features 2020 here, including remote desktop integration, two-factor authentication. Also, of course, then workshops, making it less complicated to use it for workshops. And we, in 2021, we really did a big redesign of the underneath laying system, going from Docker Swarm to Kubernetes, and in getting the connection to our storage system. That's of importance. If you're on an HPC system, of course, the data which is just on the storage is of high value, and you want to enter that data in your interactive environment. So making that less complicated, and because the whole setup was growing, we had to think about how to do modularization, and so there's quite some things to go in the background to get these up and running. Of course, it goes on. 2022, customization, allowing other projects and communities to use these tools which are running there to make JupyterLab accessible to everyone. And now, at least this is from January this year, shows that from roughly 1,000 active users on the system, there are quite some who are jumping on this kind of modern way to use HPC, at least from the point of the interface. Yeah, to enter, how does that look like? In, of course, from my point of view, I always talk about the setup at our HPC center, but it's surely similar to other HPC centers. So I hope that if you get a good idea of how this is implemented and how this can be used, then you grab your parts of this talk and use these ideas and techniques also at other centers. At our center in Jülich, we have a big parallel storage across all clusters. You see it as orange at the top, and this is connected to the HPC system. The big ones, Joules and Eureka, but also smaller ones, Yusuf, Deep, HDFML, and so that the user can go from one system to the other and having the same view on its data, independent of the system is logged into. And beside that, there's the HDF cloud, which is an OpenStack system where you can run virtual machines, containers, and so on. So on all these systems, you want to have, or at least we wanted to allow users to easily use JupyterLab. That means it must run on these resources. It must run on the HPC systems on the login nodes, but also we want to have it on the HPC systems on the compute nodes. So you really can have interactive HPC environment where you can see while the simulation, for example, is running, can even be on the same node. There are a lot of different use cases. So from here, we just ensured that it's possible everywhere, and then one can talk about how the best the best way to use it in different situations, of course, one that differs depending on the requirements of the users. One important thing to always consider is that internet access is not everywhere guaranteed, or it's not everywhere. It's on the login nodes, it's on the cloud, but it's not on the compute nodes. So one has to think about how do you tunnel the output of the Jupyter user interface to the browser. So all these is, of course, things to consider when setting up these software architecture. Okay, jump back to what is JupyterLab, and then we have a quick look at the details underneath, and after that look at the possibilities one has with these kind of environment. So what is JupyterLab? Talking about the terminology. JupyterLab, as I said, is an interactive working environment, the web browser, for the creation of reproducible computer-aided narratives. So reproducible, that's the thing to emphasize here. Of course, you want something you can pass on, and the same results can be recomputed, and yeah, what is it? A third bullet point here, very popular with researchers from all fields. That's of course also high importance, especially here from all fields. So if you have some setup on an HPC center which is domain specific, then that has of course not that much big impact as if you could use it in all different kind of domains. And JupyterLab just provides that with the software architecture, with these extensions I will talk about, and with the different programming languages it supports. So that's the next. It's language agnostic. It is written in Python and JavaScript for the browser, but mainly it's a Python tool. And I would say most of the users are using it for Python, but it's not Python specific. It is independent of the programming language. We have quite some few programming languages which are provided by default, and it is meant to be independent. So it's all programming languages it supports, and I think there are currently 50 different programming languages which you can theoretically add, and so they can use this functionality which Jupyter provides. And JupyterLab has is a bunch of extensions, and has the ability to have extension on the server side, so where your JupyterLab Jupyter server runs, or on the browser side in your browser, on the client side in the browser. And even the basic standard features, like for example the in-browser terminal or the file browsing, it's say just an extension. So you as a community, you are free to design your own extensions in there, and this is one of the many reasons why it's so popular, because you can just come up with your own ideas and use this platform to speed up the time, or speed up the the development process from the idea to really something your group, your community can use. The JupyterLab is document-centered computing. So that means you have one document, which is this Jupyter notebook. And in this one document, you can add rich text, math, plots, media, so movies, and so on. And this all in one document is called Jupyter Notebook. So the Jupyter Notebook is a document with file extension IPyNB, and it's a document that can be rendered in a web browser. It can be rendered in a web browser, but there are other renderers to render this IPyNB file. It's actually JSON format, and then you have these different renderers. If you're in the browser, of course, you would see how the render for the browser will see the results of this renderer, but you can create PDFs from their HTML files, and also use it for not providing a rendered document in the way of having something to print out, but even to create then Python code from there, or LaTeX code. So it's meant to be the starting point for different kind of renderers, and that's why it is used and at multiple places. I already said GitHub can render it, GitLab can render it, and there are different applications which can benefit from that. Next is the Jupyter kernel. The Jupyter kernel is actually the separate process which executes the code cells in the Jupyter notebook. When you go through your Jupyter notebook from the top to the bottom, you go from one cell to the next, and if you enter a code cell, then this code cell will be executed in the environment of the kernel. And the kernel is then the language you decide, but not only the language, but actually the whole environment where you want to run your code. This can mean that the Jupyter node, the Jupyter server can even be on a different node. So and then the kernel. So it's completely separated, and that's the reason why your code and what you will run through JupyterLab has nothing to do with the environment in which the Jupyter server, or actually the UI is running. And these kernels, you can have a lot of kernels, different kernels, and it's run as I said, programming language, different programming languages in environment. And this kernel is then connected to one notebook and executes the cells in there. It communicates in general, I have to say, in general, it communicates via 0 and Q. In general, also, you have multiple kernels installed. Our system, we have Python, R, Julia, Bash, C++, Ruby, JavaScript. Oh no, there are more, Octave, I think, and specialized kernel for deep learning, visualization, quantum computing, which are actually Python kernels, but which have extra packages in there. And when one thinks from the point of a user using an HPC system, you will quite quickly see that the kernel which are provided by the site will not fulfill your needs. And so you create your own kernels. And that's also something which is meant to be this way by Jupyter or JupyterLab, that users just create their own kernels, their own environment with their own packages and modules loaded and so on, to ensure that you're free to create whatever environment you need for your your codes and can share these environments with others and so on. I also said that JupyterLab supports extensions, and JupyterLab is actually a bunch of extensions. Everything in there is an extension. This is new with JupyterLab compared to Jupyter. This was much more thought as a collection of extensions, and so one can easily take the provided file viewers or file browsers and modify them to come up with a new file browser or something else. But because the community is that large, most of the time it's worth checking if not someone else already has done that. And also we provide a lot of extensions. I will come up to that later, which are kind of becoming one of these kind of most used extensions and can be used by more than just a special domain. With JupyterLab 3, the use of extension became even more powerful because it introduced pre-built extensions, which allows that the extensions do not need to be compiled in, which was the case until JupyterLab 2. So now you can compile, or you have your JupyterLab ready compiled on the system, and then you can on the fly, whenever you start the JupyterLab, add whatever extension you like. That's a big benefit for us as a HPC center, but also for you when you're on such a system to use pre-installed JupyterLabs and then enter your extensions. Just to let you know, because I think from my point of view, this was really a big step forward for environments with a lot of different users where you definitely cannot and do not want to come up with big one serves everything setups. How can you use JupyterLab? I of course talk a lot about pre-installed JupyterLab on the system, but JupyterLab is something which is easily installed locally on your own laptop with Conda, Mamba, pip and Docker. So it's nothing which is very specific and needs a lot of extra work to set up. It's actually quite quickly set up. From our point of view, an HPC center point of view, you might want to, or you need to have the Jupyter server close to your data, close to your compute, and therefore this local installation is something to work with, developing perhaps 1 or 2 lines of code or even much more. But when it comes to doing workloads and playing with big data, then you want to have a remote installation, so installation on the system. And this can again be, even if you just have user privileges, can be done with pip or mini conda in your home directory, or it's installed system-wide. And that's where I spend a lot of time getting this nice and easy to start up with the special setup, which already is customized to the HPC systems on our side. But this is not needed at all. JupyterLab is quickly installed in $home, and then you can do an SSH tunnel to your local system, and you're done. What is new and kind of fancy, just to play with it, definitely not for HPC, but it's really cool that it works for showing around how these JupyterLab looks like, is the new Jupyter Lite, which is a really 100% browser-only installation. You visit that page, and it will get not just the browser, the UI side of JupyterLab in your browser. It gets the JupyterLab server in your browser and a full-blown Python environment in your browser. So this is for going the first steps. It's a nice way. Then you do not even need to do any installation at all. So how, as I said, how does the Jupyter would run if you just say, okay, I have access to an HPC system, let's start that. Then you would start your JupyterLab on the HPC cluster. Here it's on the right. This JupyterLab is the Jupyter Notebook server, or nowadays it's called Jupyter server with JupyterLab server inside of that, but as attached to that. But starting this server, and then it provides you with the port and the token. You can then do your SSH tunnel and can connect your browser to that, and you are on the system on the login node, or you could even tunnel to the HPC node, to an HPC job, perhaps. So this is, say, a very classical setup. There you also see 0MQ. The Jupyter server is connected with 0MQ to the Jupyter kernel. If an IPyNB or Jupyter notebook file was loaded and the kernel started. And so this is the, I would say, standard setup. What we, as I said in the beginning, think it's important when one considers to make things say less complicated for the user and to ensure that you get most of the time you have every day for your science. Then one might want to say, okay, I want to have a 100% browser only solution. This comes up with new features, but in the beginning this is quite a step to do. And I would like to take you into that, at least for a few slides, to show you what's going on in the background to enable that. So here on the bottom, you already see there's this pink new box, which shows the Jupyter Hub. And this Jupyter Hub actually is then connected with an SSH tunnel to the Jupyter Notebook. And we also see the Unity IDM, which is an identity management server, and which is needed for authentication and for authorization and for starting the Jupyter. The Unicore is the one which is doing this on our side. So there are a few extras which open this new world of a browser-only HPC. Then if one would then just try that out, one would go on the website here on the left bottom, log in, click on new JupyterLab and start a JupyterLab, seeing that it's processing in the background and this connection is set up to your browser, and then you have your JupyterLab on the screen. So the benefit there is, yeah, you're on the same machine as with your JupyterLab as your data is, where your resources are, and of course it's just the first or it's the entry point to even more say tools which hopefully save time in research and allow HPC to be usable for a wider community which are perhaps not that close to HPC in the past. Yeah, just skip that slide. Of course, you know, if you log into a new service, you have some little steps to do, and these are needed that it's ensured that the accounts, of course, are connected to the right people, and the usage agreement is signed, and so on. So little things to do in the first login. And then one can and must, of course, do all these setup, which is normally done on the terminal you have to provide some interfaces to do that on the website. So not only just starting a new JupyterLab, but of course you need to know what's going on in the background. You need to be able to stop it. You need to know what the status of the system, and especially you need to be able to configure where your setup is supposed to start. So if there are multiple systems, you need to be able to say which system you want to use. You need to be able to say which projects, if you have multiple projects, accounting, where do you get your compute time from which project, and of course in which partition you want to start the JupyterLab on login nodes, but also on the as you see on the right bottom, the compute nodes on the batch or the devel or whatever. When you decide for GPUs, you get some extra things you want to configure. So the same kind of steps you also know from your jobs you might start on the HPC system with Slurm or whatever other job scheduler you are using on your preferred HPC cluster. In the background, then a few services are running to enable the connection from the left. So on the left side would be you entering to the URL and entering with port 80, or actually with port 443 with HTTPS URL, and then one needs to provide an HTTP proxy. One needs to provide these option page from where different decisions must be taken in the end and passed to in the end to Unicore, which is on the right here. And Unicore is then a service which starts the JupyterLab in the name of the user. And as soon as that is started, then the port on which JupyterLab is communicating on the HPC system then needs to be tunneled or passed to the browser of the user. This of course happens all in the background. A few more things need to be done. Here the slide from step before is everything which is in this small rectangular box where web services is printed on this dashed line. And then there are a few more other steps to just ensure that, of course, it's secure and no one can start jobs in the name of the user who's not allowed to do that. So, but everything kind of hidden from the user there. And yeah, maintenance, checking that the load balancing, checking that, checking the Kubernetes cluster and so on. I don't want to go in that, but it opens really a lot of extras far beyond JupyterLab. Having one set this up, allowing to come up with new web services which can then connect to the HPC system and are secure to use because of these kind of background services. I want to come back to the UI. I know probably a lot of people of you know this UI. Just to show you the most important things. The file browser on the left, and from there you can open the launcher. From there you can start a certain kernel, perhaps a Python kernel, and then in this Python kernel you can start with writing text or code, and then execute that code. And yeah, that's say the UI, but you can put in here, and that's important, I think, to mention that this is not just for kind of beginners, but it also gives you a complete terminal and all kind of extra features where I would say it goes far beyond the beginners, but it's more meant for experts making more profit from their limited time. So on the left side, you see in the sidebar different extensions to be added there from Git or parallel computing task or whatever you or it makes sense for the user of the HPC systems. So just going through that extensions to give you a rough overview on what is possible. As you can imagine, by far, I will not show you all extensions of JupyterLab, but the ones which we think are nice to have and which are at least have some kind of history and are there for quite some time. So you are sure they are here to stay and they're used by larger community. Extensions, which extensions are installed? One can simply see if one runs JupyterLab extension list, and you get a long list of extensions which are actually at the moment enabled. I already said there was a big step from pre-built extensions, or from extensions which are compiled into pre-built extensions with JupyterLab 3. But just to mention that, I think that's important to keep in mind if one thinks about easy and flexible setup and all the major ideas of JupyterLab, which are so valid for and helpful for the HPC community or HPC systems. Yeah, so here one sees PyVolume showing 3D with showing that WebGL can be used here inside of the Jupyter Notebook. I already told you that the output widgets can be with extensions be going far beyond the kind of normal features of JupyterLab here with PyVolume. GitLab, Git is an extension which, at least for me, is one of the everyday extensions. We are, I think, all using some kind of repositories, and of course you need to it's very helpful if they are included into the UI. Here on the left side, see the visual debugger with JupyterLab 3. It's now really part of the default installation, and thinking of especially of Python code. Here it's really the visual debugger of Python only, but this helps and speeds up development and playing around with data analysis. On the right, the table of content, yeah, that's probably more nice to have. Then Py3.js gives you access to the 3.js big world of 3.js and all its features there, again allowing to do fancy rendering in the Jupyter Notebook. On the right side, IPyLeaflet, which enables interactive maps in Jupyter Notebooks, is also one of the extensions which has been there for quite some time. There's a big community and used at different places. I think probably most of you know Matplotlib, because that's really one of the first-class citizen in the third-party extensions. NBDime is one on the right here, where one can compare what's the difference between my Jupyter Notebook from today or compared to one from yesterday. Also very important to use, I think. Can't remember always what one has changed. And I think one got that much used to repositories and histories that this is one of the must-haves in a productive environment. Plotly is something similar to Matplotlib. Okay, that's quite rough, but at least in the same category. And the sidecar here on the right is perhaps too special, but allows to have your screen better utilized. So there are also these kind of big extensions and kind of these small little ones, which also are nice to have. We provide, for example, for every time you start JupyterLab on a machine with a GPU, you also get this NV dashboard, which gives you right away a good idea of what's on the GPU, what's the load on the system, on the GPU, gives you these extras. Also something where you might think, okay, I go on the terminal, I can get all this information, of course, there too, but sometimes it's good to have them while you're working on something different to see them, and you're kind of forced to see that perhaps the GPU is not utilized the way you were hoping it would be utilized. JupyterLab goes much more beyond just being a tool for developers, but also being a tool to push your results to a broader audience. This is at least what Voila stands for, what they are into, and what we also see more and more, that results which are done on the HPC system, you want to have them published in the web, and there it is easy to come with your already set up Jupyter notebooks and create from there on a dashboard, instead of going with these results to someone who knows how to play around with JavaScript and HTML to create a dashboard. So quick and easy dashboards creation from a Jupyter notebook is also one of the benefits, where one thinks of, okay, it goes beyond just my kind of reproducible computational narrative. It is also a starting point then from there to provide dashboards with myself. So there are a lot of Jupyter extensions, at least on our side. I just put them all here. It's from as I said, these are slides from this 3-day workshop. So we just want to give you an idea that from the default installation to making it customized to the system is helpful for one or the other, but as I said, not something one is forced to use as a user. As you saw, you're free to install and do whatever you like on the system directly, even though you're just a user and not have any extra privileges. Oh, I'm very bad in time. So I think I skipped this whole section of Jupyter kernel creation. I think it's very important to have that in mind, that JupyterLab wants you to, I say it this way, to create your own kernel. You need to have your own environment set up, and it's not too difficult to do that. I want to show how much step there are. I just skip these kind of slides and come to the last section saying of Jupyter can do more. So here is one of the extensions which help a lot in the HPC environment. It's a Jupyter server proxy, which allows you to have some applications running side by side to your Jupyter server. And these applications, if they provide some web-enabled output on some port, which could be something which whatever the browser understands, then Jupyter allows you to tunnel that outside, and that helps. For example, if you have simulations running on HPC system and you have some, say, a dashboard running side by side to the simulation even on the compute nodes, and you want to have a look at these dashboard or at these web tool which provides whatever, a JSON file, then you can easily get access to just these applications through JupyterLab and through this extension, Jupyter Server Proxy. So here, for example, for visualization, you have a simulation on the right, which is running. It provides data to the ParaView server. This ParaView server runs in or is connected to a Jupyter kernel, which runs PV-Python, and that creates then images, and these are passed through Jupyter Server Proxy to the browser, and you can see live images of the simulation without having to hassle and bother about how do you tunnel things to the outer world, and just by changing the URL. So you see it in the yellow box. You see that one just adds a proxy / and the port number, and suddenly you have access to that port on the system where your JupyterLab server runs. So when the JupyterLab server runs on the compute nodes of the HPC system Joules, and you enter this URL while you are logged in, of course, to through the Jupyter Hub or to the JupyterLab server, then you can pass whatever information to that, which could be, for example, the dashboard of TensorFlow, so TensorBoard, or it could be from Dask, the dashboard, or in the next example here, I show we use that to include our remote visualization in here. So Xpra is running side by side to JupyterLab, and one can use that tunnel through the JupyterLab server to allow the user to click the button Xpra, and then in the second tab, the remote desktop comes up on the same node where JupyterLab runs. So a remote desktop just on the compute nodes where your system runs, and you can do performance engineering or whatever you need a graphical remote desktop for. So this is all possible with this extension Jupyter Server Proxy. Here I don't want to go into it. Of course, there perhaps one word to that. Of course, you always have to keep in mind you're often, at least when you're on a login node, on a multi-server system, multi-user system. When you're a multi-user system and you just start TensorBoard, then everyone can see your TensorBoard if they know which board you're using. So also the same here for Xpra, which is the remote desktop solution. You cannot just start Xpra and not worry about the security here. Even though you are logged in through your Jupyter, you still have to keep in mind when you start some web services or anything which communicates through a port, then on multi-user system, then ensure it's secured. So there are a lot of benefits using Jupyter. Here are more the, let's say, general benefits, not the special ones, which comes up when you think about what else extras can I do now on the HPC system. But anyway, that's popular among data scientists, and it becomes more and more a platform to build up other tools on top of that. And I'm still like this book on tutorials, but I just go to questions, and yeah, I have 1 minute for question, I think.
Thank you, Jens. Very interesting talk. I really enjoy it. So we have a couple of questions in the chat. So let me go through them. The first one, some of our assistants are asking for your slides if you are going to share them in our webpage.
No problem. So
so I think the best place to put that is in our RISC2 page with the information of this webinar. When there we also share the link to see the talk, and if we can put there the
Definitely.
slides, it will be great for the people. Thank you.
And I'm here to advertise this idea of interactive supercomputing.
Okay,
So
great. You did a great work. So let me. Okay. This one of the Christian is asking about what are the steps to transform a Jupyter notebook to run on an HPC cluster node, which models to call. I think how do you maybe you explained this in this last part of your talk, but I think they were thinking in like an admin and wondering about how do you connect these two worlds, like from the infrastructure point of view.
I think it was about how do you run your Jupyter notebook?
Yeah, in an HPC. Yeah, you have.
Okay, so first of all, you or the main question is how do you get your Jupyter started on the HPC system? So as Jupyter is a standard application, say it this way, if you have access to the system, you can. I try to shortly go over that. You can install it. You can, if you're lucky, the administrator has already provided some module, but you do not depend on it. It's a normal application which uses underneath Tornado to then connect to a port, and on that port, on that system, as soon as you can connect to that port with your browser, then the interface will come up. So the question is, okay, you have to install it, or you have to ensure that it is there. And after that, you have to ensure, okay, now it's running on port, say 8888 on the system. You started it on, say, in the terminal, and it will tell you, oh, I'm running on localhost 8888. And then you have to get these ports to your laptop. If you have an environment which already provides all that, like I said, with these URL we set up, then of course you're lucky. But even though if that's not the case, I mean, it's kind of just tunneling that port to your local machine.
Okay,
SSH.
let me rephrase your question. So okay, from the point of view of the user, it should be almost easy if the tool is already installed in the system. You only have to know in which port the server is listening, and you have to connect to that port and log in with your credentials, and that is all. For you as a user, you have access to the Jupyter notebook running in the cluster or in the node of a cluster. From the point of view of the system administrator, how difficult is it to set up all the things needed to carry your standard cluster HPC, a Slurm-based cluster, to enable it to use Jupyter notebooks?
Probably, first of all, you would say, okay, I reinstall it on our system, say classical way people do a module load, and we install it in a way that you can do module load JupyterLab or Jupyter, and then the command Jupyter is visible. So you have installed it, these JupyterLab as one module on the system. Of course, that just helps your user in that way that they can say module load Jupyter, and then they can type in Jupyter space lab and enter, and then it will start and show the port number and the token which they can use to connect. If you go the second step and you say, okay, I want to really have the user not being necessary to log into with SSH to my system through terminal, and I want to make it browser only, then you first have to ensure you have an identity management system where users can log in, and this can be whatever identity management system. At our system, then, or it must or should talk with OAuth, and this identity management system needs to be connected to Jupyter Hub. Jupyter Hub is, say, the one which is doing most of the kind of managing the users and showing the web page and the options and so. And the last thing, or the one thing which really has to be considered when one goes with these, say, full-blown setup, you do not want to have Jupyter Hub having root access on your HPC systems, but Jupyter Hub needs to be able to spawn Jupyter notebooks, the Jupyter command in the name of the user. So this is something, at least from my point of view, one really has to ensure that this is completely decoupled. And of course, you can just install Jupyter Hub on your system and say, okay, it gets root and it can just spawn Jupyter notebooks, Jupyter Labs in the name of the user. But you then always update your Jupyter Hub, and who knows if there's some code you do not want to run in the system one day. And there we use this Unicore to decouple it. So the Jupyter Hub itself on our side is not allowed to spawn anything on the system. It just can tell the Unicore service, which is there since 20 years and it's trusted, yeah, there's something I would like to spawn. And then Unicore will check at the identity management system, is this token valid? Does this user has access to this system, and so on? And then this special service, Unicore in our case, will then, in the name of the user, start the JupyterLab. So I think the first step is easy for admin to just install JupyterLab, making it available as module load with module load or whatever other way, just to help the user. They don't have to install it. The second step is going through browser-only solution is really something one should be aware that it takes time. But I think it's worth it. Yeah. Does that help?
Perfect. Yes, I think it's very clear. I have a couple more questions. This is Agustin was asking about how a user include information about the resources needed for a command. I mean, you just spawn your JupyterLab and maybe you need 24 cores to run one line of the one cell. How do you interact with the system to tell, okay, for this command, I need this amount of resources. For the next command, I need a GPU.
This is actually not what JupyterLab provide. Of course, it would be great if you could go from one cell to the other and then change the environment and say this cell goes to that resources, this cell to that resources. And if you put something in between, this is, I would say, theoretically possible. Actually, in our system, it's not. But I would love to have it. But from the point of JupyterLab, it's you run your whole notebook in, or the whole notebook is run by this one and single Jupyter kernel. And this one single Jupyter kernel is just an environment which you can pass these lines of command lines to, and it will execute it. So there's running, say, an IPython in this kernel, and it just takes these command lines. And of course, you can now think of, oh, why not putting something in the kernel which can handle that? For example, if you go with Dask and say, okay, in the kernel, I use Dask to do some parallelization. Okay, that will not, and have some, and Dask will now do these creative virtual cluster and all this stuff. But this is then some feature which comes with Dask or some other extra tool you might have, and which runs in the Jupyter kernel, and you use that. So it's not, I would say it's not the business, at least at the moment, it's not something which JupyterLab will do for you, but you are free to use two JupyterLab tools which will do that.
Okay. So you have to do, for the moment, at least, manually having the number of Jupyter notebooks open in different kernels, depending on the amount of the type of resources you need.
Yes. Perhaps one thing we are actually working on, and I really think that has a big future, this extension is Elira. Elira allows you to have workflows, complicated workflows, where you have multiple notebooks and you say, first run that book, and then this one, and then this one, and then this one, and in parallel that one. And you can, in JupyterLab, design your workflow, and then this is pushed to some workflow engine. As I said, JupyterLab itself is not meant to be this kind of workflow engine, but there are a lot of workflow engines, and here Elira then pushes it to Apache Airflow or to Kubeflow, or you can come up with others, and this will then run these Jupyter notebooks on the system and pass the information back to the environment. But JupyterLab is more the UI on top. Yeah.
Well, I have one more question from Leonardo, who is asking, he's asking about which version of NFS or parallel file system are you using in this setup you mentioned?
So as I said in the beginning slide,
I think the big one, yes, yeah, you are sharing
that's a GPFS file system.
GPFS.
And from the cloud, GPFS then made available through NFS, but hopefully, in the best case, the user does not have to worry or does not have to think much about it. We have decided years ago that our big one is GPFS, and that allows it nicely to have this one file system for all the ABC clusters and else.
Okay, and you are happy about their performance? And
we are never happy. We always want to get better. No, but yeah,
but you accept it. It's you are.
No, it's doing a good job. It helps, at least from me personally, who are more on building on top of that to make things possible, which would not be possible if they would be separated, all these clusters having their own file systems.
Yes, Ricardo is asking if you can say one or two tools to manage workflows. I think it's not specifically for Jupyter workflows, but Jens was mentioning that there are a lot of tools, like mature tools, to program your own workflows and have it the engine run each step of your workflow in different infrastructures. I can't remember a name. Do you have one of these tools as an example in mind, Jens?
Yes, it's as I said, this Elira. Of course, I have more slides. Okay. You can even give me more slides. This Elira is something we couple with Apache Airflow. On the right side here, the workflow engine, you see the Apache Airflow. There are multiple reasons why we decided this is something to focus on. I once talked to a group of different workflow engine developers, and actually it came out that you can even say Python is the workflow engine, but I think that's perhaps a little bit too simple. Apache Airflow is just the opposite. It's really big and full blown. Nowadays, if you have the possibility to start somewhere VM and then just run containers there, then hopefully even these big workflow engines are set up quickly. Of course, we always think on how can which workflow engine gives us benefits for cross-domain for all different users and different use cases. So I have to admit, I'm not a workflow engine expert. We looked at a few and then more or less were convinced with Apache Airflow because it fits good in all our complete setup. So thinking about Jupyter and Elira and the workflow engine. So probably this answer is not really fully what you were hoping to get. This is too far away from my everyday work that I can say take that or that.
I think you just mentioned one powerful tool. So to start from scratch is okay. I think I have one more question. This is from the point of view and architecture of the cluster. Usually, I mean, in the previous HPC, we have a lot of nodes with the Slurm. The people just log into the head node and run and submit their job to the batch queue, and wait for the results. If you now have a set of nodes, do you think it's better to split these nodes statically, some of them for standard HPC shops and some of them for interactive shops like a spawn of JupyterLab? Or do you think it can be done two functions or two type of tasks in the same set of nodes, just using some kind of interface with Slurm to launch the interactive shops?
The critical thing is that people who are sitting in front of the browser and clicking on launch my JupyterLab, they are not willing to wait longer than a minute. Okay, say perhaps 5 minutes if you show them some progress, but not much more. And so if we're thinking about the classical HPC setup, of course, you start your job and it might start at 3 o'clock in the night. So there's no option at all. And now if you're on the same partition and it's really crowded, and then you start your Jupyter, then on at least our setup, there's no real big, or there's no difference at all. There's in the background, a Slurm job will set up, and this will be put in the queue. And if you do not have the privileges, or you have no reservations on the system for workshop, for example, and you really have to compete with the others in the same way, then this can take hours. And of course, that's no option. If you really want to start, and that's another question, the question, do you really want to start your interactive HPC in the same size as you do with your big HPC jobs? Probably if you say, okay, I want to do interactive HPC with 200 nodes, then this is a lot of waste of compute time, and most of the users looking in our setup, they are just running on 1, 2, or 3 nodes to try something. And then if you want to try something and play around, then you are happy if you start your setup on the devil partition, and it's quickly up and running. Thinking more into the future, where we would say, okay, I also have interactive jobs where perhaps the human in the loop is not something which stops the things, but it's more looking inside while the setup's running. Then of course you think into a direction where you say, okay, I start my simulation, and then I want to connect to that simulation afterwards at some time, because it's running 24 hours, so I can connect. Then you also do not have this problem. So I say it's really difficult, and we have to find out good solutions for that. The administrators, they would like to use high full queues and not too much resources which are idling. That's of course something which is completely against the idea of interactive supercomputing, because you need to have resources available right away. Something in between could be preemption, saying that when you start your interactive job, that then other jobs might go into sleep, and these resources could be used, and they start running again afterwards. But this is also something we are looking into. It probably will still take some time, even though technically it's possible, but it has all these little issues when you think about accounting, when you think about why should which job stop, and what happens if someone is waiting for a result and you suddenly stop that job. So the probably most easiest is if one would have separated partitions, and if one thinks about changing the definition on how well or good an HPC partition is serving the user. When we say the best HPC partition is the one which always has a full queue, then this is definitely not working with interactive HPC. But if we say the best partition is the one which starts my job in maximum of 3 minutes, then this would work very well with interactive HPC. So it's, yeah, sorry, it's not working well side by side. It's always a compromise.
Mm-hmm. Perfect. Clear. Very clear. Thank you. Well, I think we passed through all the questions, even mine. So I think we are on time now. Thank you, Jens, a lot for your talk. It was really, really interesting. And I have to tell you, people, that we have the next webinar will be on October 19 at the same time, same channel. And it will be given by Marc-André Hermans, and he will be talking about application benchmarking. So it is also a very interesting topic for our field. So schedule this date, October 19. We'll be advertising this event in the standard channels. So, well, thanks a lot, Jens, again, and see you in the next meeting. Bye-bye.
Bye-bye.